folks, let's take a look at example 6. So in example 6, we're given 2 points and we're asked to find the equation of an exponential function. So this is like example 5 in that we're given 2 ordered pairs. It is unlike example 5 in that neither of these are the y-intercept. So in example 5, we were given an ordered pair like 0, 1, 29, and that made it that much faster for us to find the a value. We were not given that here, so it's gonna make things a little bit more complicated. So let me go ahead and take a moment and write that out for us, just so we're seeing it. All right, so we were given these 2 ordered pairs, which is still gonna allow us to find a and b. And when I say a and b, if we want an exponential function, right, we know our exponential function looks like a times b to the x. So since I have 2 letters here and 2 ordered pairs, I will be able to find a and b, but neither of these, because neither of these, I'm gonna put unfortunately, all right, because neither of these are the y-intercept, I can't directly find my a value because neither point is the y-intercept. I cannot directly find my initial value. Right, i.e. the a value. If one of these, if this had said, what would have been lovely is if this had said 0, 3, then I would have known a was 3. And that's usually where I start my problem with my y-intercept, but I don't have it this time out, and that's okay. It's just gonna make this a little bit more convoluted. All right, so what I am gonna do is I'm gonna throw each ordered pair into this function and see what comes out. So I'm gonna split this, I'm gonna separate this a little. Let me start with 1, 3. Keeping in mind that this is my function. So if I did f of 1, right, if I plug 1 in, I'm gonna get a times b to the 1, and apparently that's equal to 3. Okay, now I'm gonna try f of 2, right, and when I plug 2 in, that's gonna be a times b squared, right, a times b to the x, and apparently that's equal to 4.5. So here I get AB equaling 3, and here I get AB squared is 4.5, right? Because I initially, my x value was 1, and then 2, right? A times b to the x. If x is 1, that means AB. If x is 2, AB squared. What I'm going to now do is solve each of these equations for A. All right? So if we know AB is 3, I can divide both sides by b. This is going to cancel by design, and I'm going to get a equaling 3 over b. Here, we know ab squared is 4.5, so I'm going to divide both sides by b squared, right? Cancels by design, and I'm going to get a is 4.5 over b squared. All right, so I solved both of these equations for a, and then if a equals 3 over b, and a also equals 4.5 over b squared, then through transitivity, I can set 3 over b equal to 4.5 over b squared. So now I know 3 over b is equal to 4.5 over b squared. And the good thing about this equation is now I'm down to one equation, one variable. And because I have 2 proportions set equal to each other, I'm just going to cross multiply. So if I cross multiply, I'm going to get 3b squared equals 4.5b. And I have a quadratic equation. So I could factor, complete the square, use the quadratic formula. I'm going to opt to factor. So what I'm going to do is I'm going to set this to 0 by subtracting 4.5b from either side. So if I subtract 4.5b from either side, right, I'm looking at 3b squared minus 4.5b equals 0. Okay? All right, now again, if you're not loving factoring, right? Because some people don't, not a problem. You are more than welcome to use the quadratic formula. You could let a equal 3, b equal negative 4.5, c equal 0. I'm going to opt to factor, so I'm going to move this up here. Okay, so let me rewrite my equation. I'm looking at 3b squared minus 4.5b equals 0. I'm going to factor out a b, and I'm going to get 3b minus 4.5 equals 0. And then I'm going to use the zero product property. So either b is equal to 0 or 3b minus 4.5 equals 0. And again, if you don't like this factoring shenanigans, go ahead and use the quadratic formula. Oop, I just see my page is really shifted. Let me even that back out. My bad. All right. So again, you could have used the quadratic formula with, if I'm using a equals 3, b equals negative 4.5, c equals 0. And I know that we have a double use of the letter b, but it's okay. All right. So b equaling 0 is not going to be the correct number for b because I definitely have exponential growth, right? I grew from 3 to 4.5. So this b number has got to be larger than 1. Okay. So I'm going to go ahead and solve this one. I'm going to add 4.5 to either side. And I'm going to get 3b equaling 4.5. And then the last thing I'm going to do is divide by 3. And when I do that, let me head over to my calculator. So I've got b is 4.5 over 3. So let's do 4.5 over 3. And that's the number 1.5, which is great in that if I'm solving for b, I should get a number larger than 1 because we've got exponential growth. Anytime you have exponential growth, b should be larger than 1. If you have exponential decay, b should be less than 1. Like maybe if b was 0.5, then I could say I had a decay. And if b is ever 1, you're at equilibrium. You're neither growing nor decaying. Okay, so I've got b. That's half the battle. We still got to go figure out a. All right, so at this point, I know b is 1.5. I'll substitute that in a bit. But we know a. A is either, you could do 3 over b, or you could do 4.5 over b squared. I'm going to use the simpler version. So if a is 3 over b, in this case, that's going to be 3 over 1.5. And maybe you can see that in your head. Maybe you can't, all right? But if I do 3 divided by 1.5, it's number 2. So I've got a equaling 2 at this point. So I know my b value. I know my a value. So I can finish this problem out. If I want to get my exponential growth model, this is going to be f of x is going to be equal to 2 times 1.5 to the x. All right, and this says whatever this population is, it's growing at a rate of 50%. All right, 50% per time unit. And I'm getting 50% because again, equilibrium was 1, and then the decimal we added to it was 0.5. And as a percentage, that's 50%. So whatever this context is, and I don't know what it is, but it's growing at 50%, and I'll say per time unit. I don't know if that's per year, per month, per minute, because they didn't give me any context, but I just kind of want to break that apart for you. All right, thanks so much, everyone. Bye.